Hi, this is the first of a series of presentations on the ongoing debate between science and creationism. Over the coming weeks, I'll be releasing a series of videos taken from my lecture series on this topic, which is available on my blog at www.frame.net. The aim of these presentations is to help you to understand why there is such a strong scientific consensus in favour of the theory of evolution, and to learn a little about the evidence behind it. Today's talk is about science in general, what it means to do scientific research, and how to tell the difference between scientific and non-scientific claims. But after this, I'll be going into a lot of detail on a wide range of creationist material. In fact, it's going to be pretty rare for you to meet any creationist argument that I won't cover at some point during this course. And that's because I've taken as my source material the lengthy presentations of everyone's favourite tax-dodging young earth creationist, Kent Hovind. Yes, I've personally gone through over 6,000 slides in Hovind's entire presentation pack, so you don't have to. And believe me, you wouldn't want to. During these talks, I'll go into details about specific claims, and I'll also give a more general overview of each topic. Most importantly, I don't want to waste all my time pointing out why nonsense theories can't be true. I'll also cover what is true, and how we know it to be so that you'll get an understanding of how the universe actually works. These slides are not directly designed for use in debates. For a start, they're fairly text-heavy. If you're giving a talk on science, then I strongly advise you to write the main part of your presentation yourself, to fit in with your own style and personality. This definitely isn't a quick or easy task. There's a lot of information here because the absolute biggest mistake you can make is to go into a debate assuming that all creationist arguments are trivial and stupid. This is definitely not the case. Many creationist arguments will be from parts of science that you simply won't know about unless you do a great deal of reading beforehand. Some are extremely complicated and specific, focusing on very specialist areas of research or referencing obscure news items. Moreover, creationists will probably have heard most of the more common responses to their claims and will have answers prepared to deal with them. So, on that note, let's get started. So, before we go any further, let's clarify right from the start what science actually is. Creationists will always try to claim that evolution is just a belief or even a religion, so you have to be prepared to explain why it isn't either of those things. The theory of evolution is a cornerstone of biology, but it's intricately woven into and supported by all manner of other sciences too. If evolution is wrong, then so is most of modern science. Evolution isn't a crazy fringe belief within biology, and it's not proposed by a cult of Darwinists. It's accepted by practically every single working scientist alive today, minus a tiny minority with very strong religious faiths. Evolution isn't just an opinion that people hold because it suits their tastes or personal preferences or lifestyle. It's a real scientific theory which scientists accept because the evidence is so overwhelming. True, some scientists believe in a theistic evolution, which is to say evolution tweaked and directed by some god or gods. But most don't, and those who do would readily accept that this embellishment is definitely not scientific. It's just a personal religious belief. You won't find a serious scientist who believes in the young Earth hypothesis, that is, that the Earth is a few thousand years old instead of billions, because belief in a young Earth is simply not compatible with rational thought. Science is not based on opinion, intuition, dogma, or desire. That is, we don't believe things are true because someone told us they are, or because we feel like they should be true, or because we've been instructed to believe them under threat, or because we really want them to be true. None of these is a good reason to believe in the truth of any claim, no matter how important. Instead, science is a rigorous process which gives us a way to discover new information about the universe while avoiding as many potential sources of error as possible. Because of this, the scientific process gives us the maximum confidence that what we learn is true. Sure, there are other ways you could learn about the universe. You could randomly choose things to believe by rolling dice, or you could accept everything you read in your favourite tabloid newspaper. But that gives you no information at all about how likely those beliefs are to be true. And as scientists, it's truth we're most interested in. So we need a method that allows us to assess our beliefs, to see how closely they match up with reality. So that's an introduction to science, but what's creationism? Creationism is the belief that the universe was literally created by some kind of supreme being, rather than being formed by natural physical processes. This creator is usually identified as a Judeo-Christian God. Young Earth creationism is the belief that this creation event happened in the last 10,000 years or so. Often the date of this event, derived from biblical chronologies, is somewhere around 4004 BC. That puts the age of the Earth at something like 6,000 years, rather than 4.6 billion years. To put that into perspective, it's like saying that the distance between New York and Los Angeles is about 5 meters, or 17 feet. Or equivalently, it's like saying that the average human lifespan is about 45 minutes. So now we've met the contenders, let's go back and look at how the theory of evolution came about. How does the scientific method actually work? Well, science starts from the understanding that human beings are not naturally very good at gathering accurate information. Anyone who's ever been fooled by a magic trick or a clever optical illusion will know this all too well. We often believe things without any justification, like rumours and scare stories. The scientific method aims to take us out of the process as much as possible, or at least to compensate for the known biases of the human mind. Science puts forward explanations, or hypotheses, to explain a certain phenomenon. A good example of this is the hypothesis that the Earth is more or less spherical. Another equally testable hypothesis is that the Earth is flat. Often we build theoretical models to explain these hypotheses. For example, a question might be asked, if the world is not flat, then why does it look flat? And why don't people fall off the bottom of it? The model used to explain this might involve the huge size of the Earth, which looks flat locally. It might include an explanation of local frames of reference and, of course, gravity holding us onto the surface. Notice that these hypotheses have a very important property. They're falsifiable. That is, it's possible to gather data to discern which, if either, of these models is true, or, importantly, to prove them false. So that's exactly what we do. We gather data by doing experiments. You could imagine a suitable experiment to test the shape of the Earth would be to travel for a very long distance eastwards along one latitude and see if we wrap around and return to where we started. We could also leave the Earth in a rocket and look back at the planet as we move away from it. There are, of course, many other possible experiments, including the one used by the ancient Greek scientist Eratosthenes, who estimated the size of the Earth by examining the length of shadows cast by sticks pushed into the ground in two different places many miles apart. Gathering this evidence relies on using unbiased experimental methods. For example, in the case I just mentioned of Eratosthenes, he had to make sure that the sticks whose shadows he measured were of identical length, and both perfectly vertical. He had to measure the shadows with a reliable ruler exactly when the sun was highest in the sky in each location. That ensured that the measurements could be safely compared. What he noticed was that, as he moved towards the equator, the length of the shadow cast became shorter, because even though the sticks were locally vertical, the curvature of the Earth meant that the sticks were pointing at slightly different angles. From this, Eratosthenes got a very good estimate of the size of the Earth, in around 240 BC. Once we have our evidence, we need to have some way of assessing a hypothesis or hypotheses in light of what we have discovered. Perhaps we can reject one, or maybe both of them. Either way, we've advanced human knowledge. The final two stages are vital to this process, but are usually absent in pseudoscientific claims. Firstly, scientific proposals must be subject to peer review. That is, they must be analysed and criticised by other experts from the same field of research, to make absolutely sure that the conclusions proposed are watertight. And finally, as a result of all of this, any hypothesis must always be open to re-evaluation. Maybe new information has come to light which makes a previously plausible hypothesis much less likely, or more likely. Either way, science is an ongoing process which must seek to improve its theories constantly. Scientists must have the ultimate in open minds. They must be ready to embrace any new theory, or to abandon any existing one, whenever the data, the theory and the analysis suggest, but only then. So, to summarise, this is how science is done. We propose a hypothesis, we make predictions based on this hypothesis. These predictions are tested based on reliable evidence. The evidence is assessed to see if it supports or denies the hypothesis. The evidence and the results deduced from it are subjected to rigorous review. Results are published openly to maximise the number of reviewers. Results are always open to modification if a superior theory ever arises. Now, of course, reality very rarely aligns with these ideals. In practice, science is a messy business. It's performed by human beings with emotions and personal agendas. Despite the best efforts of all involved, it can be subject to bias, short-sightedness and error. But what's important to realise is that the scientific method is not at fault, merely our attempts to follow that process. And let's face it, science does pretty well despite these occasional failings. This is why we insist on processes of peer review and continual re-evaluation to minimise the problems of bias. Now that you know what constitutes a science, it should be obvious when you compare a scientific hypothesis with a pseudoscientific or unscientific one. A common creationist claim is to suggest that parts of well-established science are not actually science at all. In general, this is a smokescreen. They're trying to pick holes in pedantic parts of scientific technique to divert attention from the fact that their methods are 1,000 times worse. A science conforms to the scientific method. Anything that doesn't is not a science. It's as simple as that. The bottom line here is that the theory of evolution is a science, and demonstrably so. It follows every single part of the scientific process. It's supported by lots of evidence, it has solid theoretical foundations to back it up, it makes testable predictions, and it fits beautifully with the rest of science. Another common claim is that there's no evidence for evolution. After all, how can you have evidence for something that you can't actually see happening? We can't travel back in time to watch millions of years of evolution pass by, so how can we ever claim that we have evidence that it occurred? Again, a little thought shows this argument to be completely hollow. What does it actually mean to have evidence for something taking place? Imagine a murder trial, for example. Think of the kinds of things that are considered strong evidence. Can we convict without any eyewitnesses? Yes, of course we can. In fact, I guess that most murder trials have no direct eyewitnesses to the actual murder being committed. What kinds of evidence could we gather for evolution? Well, for a start, there's the fossil record. There's also a huge wealth of information coming to us from the science of genetics, which I'll talk about in a later presentation. We can make testable predictions from the theory of evolution, predictions that, were they shown to be false, could easily falsify the entire theory. But time and time again, the predictions turn out to be accurate. You most certainly don't have to see something happening to know that it's true. But we actually can watch evolution happening in human timescales. All we need to do is to watch organisms with extremely short lifetimes, measured in hours, not decades. For example, a team from Michigan State University have been watching the evolution of populations of the bacterium Escherichia coli for over 50,000 generations, during which time they've seen substantial changes occur. Other teams have examined the evolution of viruses, such as hepatitis, within individual patients. So we can watch evolution occur. Another common technique is the claim of creationists that they aren't anti-science. In fact, so they continue, they're actually scientists themselves, just searching for the truth. This is a really common technique of most conspiracy theorists and pseudoscientists. Just because someone claims that they're a scientist, or even if they have a scientific degree, it doesn't mean that everything they say is scientifically valid. Plenty of people with Nobel Prizes in scientific subjects have come out with outrageously unscientific notions, which were subsequently shown to be completely false. So let's look at the implications of creationism. On this slide, I list just a few of the sciences that must be thrown out if young Earth creationism is right. Now, just because a hypothesis disagrees with a huge amount of established science, that doesn't mean that the hypothesis is unscientific. But it certainly means that anyone proposing it had better provide some pretty hefty evidence to back up its claims. After all, that's what a science does. The bottom line is that creationists want us to throw out all of these well-established facts, all built up over centuries on mountains of undeniable evidence, and replace them with their own specific mythology. And they want this to happen based on dogma, essentially because they've read a book that says so. They want to throw out peer review and critical analysis, and replace them with credulous and uncritical acceptance of Bronze Age stories, without any evidence. Not only is that clearly not a science in any way, shape or form, but it's also obvious that the scientific process is their number one enemy. So yes, they are very much anti-science.